Okay, so we're going to do most of Chapter 5 here before Christmas break and we're reviewing for our final, and it's called Mathematics of Finance, which actually is some really good stuff to have just for life. Also, if you take a stats class in college, it might show up again. But hopefully, if you've taken Algebra 2 or Pre-Calculus, then you've seen some of these formulas I'm going to show you today. So first of all, compound interest is what we're talking about today. So basic interest formula is interest equals principal times rate times time. So principal amount is always like your starting amount. Your interest rate is usually given to you as a percent, so you change it to a decimal. And then usually times in years when we're talking about accumulating interest. So that's just how to figure out how much interest there is. If you want to know the accumulated amount, like how much is there after, you have to add in the principal amount. And so notice that this is just like the principal amount plus the interest. But it's just 1 plus the rate times the time times your starting amount, okay? So it says the bank pays simple interest at the rate of 4% per year for certain deposits. If a customer deposits $1,000 and makes no withdrawals for 3 years, what's the total amount on the deposit at the end of the 3 years, and what's the interest earned? So this is all about earning interest, which means that a lot of us don't have this idea of where we just have money sitting there that we aren't touching. But if someone gave you a savings bond or a amount that your parents put in a savings account when you were born, then maybe this would be. But this is a lot of people do this with like CDs and other things that I don't have the money to do. But I can my formula here that says the amount is going to be the principal times 1 plus the rate times the time. So I started with $1,000. And the rate is 4%, so that's 0.04, and we're not going to touch that for 3 years. And if we use our calculator, then 1,000 times 1 plus 0.04 times 3 is $1,120. So that is the total amount after 3 years. And then it says, what's the interest earned? We have 2 options to do that. One option is if we started with 1,000, we can just take 1120 minus our starting amount, right? And that's going to be $120. That was how much interest we earned. The other way you can do that interest is just principal times rate times time. So if you take 1,000 times 0.04 times 3 years, you're going to also get $120. Okay? I don't know what a T-bill is, but it says, suppose that Jane buys a 26-week T-bill. I've always thought of this as like a CD is what I always see advertised at the bank. But it means like you buy something for like half a year or a full year, you can't touch it, and then you get so much return. Okay? So it says the maturity value on this is $10,000. So at the end of 26 weeks, she's going to get $10,000. She put in $9,850. So I want to know what is her rate. So on this one, instead of asking the total amount, they're giving us the end amount and we're solving for the rate. So notice on this one, we're going to start with the same formula. A equals P times 1 plus RT. This time I know the ending amount is $10,000. I know the starting amount is $9,850. What I don't know is the R there. Well, what I put in for time here, if time is in years and it's 26 weeks, that's a half a year, right? There's 52 weeks in a year, or 0.5 there. So now we just get to do some algebra here. If I subtract this over, right, 1,150 equals 1 plus 1/2 R. And then I subtract 1 over, and I get 1,149. It's like I've done something wrong. Oh, I know why. Okay, sorry. I'm not subtracting this, right? Algebra. This is 9850 times this, right? So if I'm going to move this over, I have to divide it. Sorry, I knew I wasn't going to get a percent, and I knew something was wrong there. So if I take 10,000 divided by 9850, I get 1.0 1.015228426. And although this is a decimal, I'm not going to round until the end. So write the decimals down, okay? Here we go. I'm better now. Now I'm going to subtract 1, which just gives me that decimal, 0.015228426. And then to solve that for r, I'm just going to divide by 1/2, or that's the same as just multiplying by 2. So subtract 1 and then times 2 in my calculator, and I get that the rate is 0.0305 if I round. If you think about that as a percent, that's a 3.5% return. Next time you're in a bank, look at the things being advertised and you'll see that they advertise things like this where you can put in so much money and you're guaranteed so much percent return. Okay? More often, instead of seeing simple interest, we see compound interest. Compound interest is interest that is accrued more than one time a year. So it says interest that's periodically added to the principal and thereafter itself earns interest too. Like usually it's quarterly or monthly is what you see. So here's your formula. A equals P times 1 plus I to the nth power. But notice that I equals R over M and N equals M times T. And so I usually write it like this. If I'm using these letters, I would say 1 plus R over M to the MT power, which is the same as this, but then I don't have to think about what I is. I is the interest, like the rate divided by the number of conversion periods per year. So if it's monthly, M is 12. If it's quarterly, M is 4, right? T is the number of years, and R is your interest rate, and then P is still our principal amount, our starting amount, and A is the amount after so much time, okay? So it says find the accumulated amount after 3 years if $1,000 is invested at 4% per year, compounded these multiple ways, just to kind of practice doing this. And to see how does the interest change if it's compounded differently. So compounded annually means that that's only one time a year, right? So again, I'm going to write my formula here. A equals P times 1 plus R over M to the MT power. So if I do it annually, that means that M is just 1. So all of these are going to have the same numbers for lots of stuff, right? I'm going to have 1,000 times 1 plus 4%. But this is what's going to change, 1, and then to the 1, because it's annually, and times 3. So then think about for semi-annually what that means. Semi-annually, if you have a semi-annual sale, it's a twice-a-year sale, right? So semi-annually means twice. So now I'm going to divide by 2, and now I'm going to take that to the 6th power, because it's going to be 2 times 3. I would just write 6 in my calculator. I'm going to use my calculator at the end here. C is quarterly. Quarterly is every 3 months. So 3, 6, 9, 12. That's 4 times a year. Or think about there's 4 quarters in a dollar. 4 quarters in a basketball game. So now I'm going to raise that to the 4 times 3 power. And then what about daily? Daily, let's just go with 365 days in a year. So now we're going to divide this by 365, and we're going to raise that to the 365 times 3 power. And then let's see what happens with our numbers when we do this. If we do just one time a year, that's really just the same formula that I gave you, right? And so I think that I get just 1,000 on this one, $1,081.60. But if you look at part B, if we do this, oh, I don't think this is right. Goodness gracious. Okay, sorry. I was trying to cheat. Oh, no, just kidding. Okay. I was trying to just take the answers from the book, and I copied from the wrong place. Mostly, you should practice typing this in your calculator. $1,124.86. And we'll practice this in class to make sure we can get the answers here. If you do it twice a year, it's not going to change a lot, but now you have $1,126.86. $2 more. If we change it to quarterly, you actually get less money. Is that true? That's crazy. Did I skip one? Oh, look, I did the E, didn't I? D would be monthly, would be 1,000 times 1 plus 0.04 over 12 to the 12 times 3 power. For quarterly, you get $1,126.83. For monthly, you get $1,127.27. And this one you get $1,127.49. So you can kind of see what's happening there. Just to kind of practice with the formula. So then that kind of leads, like, what happens if interest is compounded constantly, more than daily, but continuously? And so then that leads us to this. And again, if you've taken Algebra 1 and or pre-calculus, you should have seen this formula before, where E is the number E, the natural exponential function. And so what if we did accumulated amount after 6 years if $1,000 is invested 4% compounded continuously? So if it says continuously, it means you use this formula. So I'm going to do 1,000 times E, I guess I don't need a parenthesis there, E to the 0.04 times 6 years. So you don't have a M value to plug in there. And if you do that, you get $1,271.12. And again, we want to make sure that you can use your calculators to do this. Okay, so we're going to stop there today and practice using these formulas, but we're going to get into like car payments and retirement plans and mortgages. And so hopefully this will be a useful chapter for you.